In this video, I want to talk about the role of parentheses in addition problems with 3 or more terms. So let's look at something like a plus b plus c. When we look at this problem, we're supposed to add left to right. So we take a, we add b, and then we add c. But what if I don't want to do that? What if I want to add b plus c first? Well, this is where parentheses come in. We would write a plus, and then the b plus c in parentheses to indicate that we should do this addition first, and then the addition with a. As an example, 17 plus 18 plus 2. Starting in parentheses, 18 plus 2 is 20, so now I have 17 plus 20, which is 37. Now let's think of a problem like 7,384 plus 999 plus 1. The way this is defined right now, we need to add these first two numbers together first. We can also denote that by putting parentheses around the first two numbers. However, if I were to rewrite this problem, this time with parentheses around the last two, we can see that this second version, is much easier to solve. 999 plus 1 would be 1,000, and then it would be easy to add 1,000 to 7,384. And in fact, these two ways are equal. These are equivalent ways to write this expression. The associative property of addition tells me that I can move parentheses around in an addition problem. A plus b plus c is the same thing as a plus b plus c. In using the associative problem, I can take this problem up here that's much harder and solve it instead this way, moving my parentheses to the 999 plus 1. The associative property for addition is true for all numbers, but I want to look at why it makes sense with this specific example. Let's think of 2 plus 3 plus 4, and 2 plus 3 plus 4. I'm going to think of this in terms of marbles. Let's suppose I have blue marbles, red marbles, and purple marbles. So I went ahead and drew this to model each problem. This one on the left here, we're combining our red and blue marbles. And then once we have our red and blue marbles combined, we want to add in the purple marbles. So I went from having 2 plus 3 and then plus 4 to 5 plus 4, or 9 total marbles that we have together. If we look at this other side here, we start by combining the red and the purple marbles, and then we add in the blue ones. And then we have our large group. So up here, we had 2 plus 3 plus 4. When we added the red and purple marbles, we got 7. And then adding in the blue gives 9. And there's nothing unique about these starting numbers. It doesn't matter which one of these two situations we look at. The addition problem on our way down to solve this may look slightly different. However, we should get the same number at the end, because either way we're combining 2 blues, 3 reds, and 4 purples.